Hello, everyone. I hope the audience can hear us and see us. I see on the right-hand side that about 40 people already joined our session. So welcome everyone to session P2 on policy impacts, on policy effects. And we have 4 presenters with us, perfectly balanced, two scientists from Germany, 2 from France, two men and 2 women. And well, I will not take more time and pass the word to Daniele Malerba from German Development Institute and his presentation. The floor is yours, Daniele.
Okay. So the presentation should upload now, right?
Yes, sorry, one second. Sorry for this.
No problem. Okay, perfect. So thank you, everybody, and thank you for the opportunity for presenting here. Of course, it would have been better to be in Barcelona, but I think this is also a very good kind of opportunity to share ideas and research. So in this presentation, I will present a paper which basically tries to look at achieving lower carbon lifestyles through a top-down policy more than a bottom-up approach. And this is a joint work with Anja Gensch, who is now at the Ministry for International Cooperation in Germany. And before she was at the University of Bremen, and also with Hauke Ward, who is at the University of Leiden, and before was at the Mercator Climate Change Institute in Berlin. So what I will do in this presentation, I will look at the motivation, the context of the research, and especially outline the research gap and the research question, then go a little bit through the data and methods, and then look at the results and the conclusions and the policy implications. So the starting point of the research was that a lot of trade-offs and synergy will exist when we look at achieving different sustainable development goals, especially because the SDGs encompass the 3 different dimensions, the economic, the social, and the environmental one, which by nature encompass these trade-offs. And we look at this issue of policy mixes and trade-offs in the context of carbon pricing and especially carbon taxes. And the reason why we do this is that carbon taxes are considered, especially by economists, as a very efficient instrument to reduce CO2, but overall greenhouse gas emissions. And due to their efficiency and the push for this policy, we have that the number of implemented policies are increasing. So in this graph, I put here the increase of the number of policy in blue and the share of emissions covered from 1990 to 2020. And you can see that by 2020, around 20% of global emissions are covered, but this is just a project implemented. Well, if you look at the countries that actually have agreed or have planned to use these kind of policies, more than half of global emissions are covered. And the other important issue is that it's not just the amount of emissions, but it's also a spread, the cross-country spread of these policies. On the map, you can see that even now, the implementation of these policies relates not just to high-income countries, but also to low-income countries. And of course, the main example is China with the emission trading scheme. That is, of course, the biggest program in the world. So we have that these carbon taxes or carbon pricing schemes are increasing worldwide. But the problem with these schemes is that they may have potentially negative effects on poverty and inequality. And the reason behind this is that lower income households spend more proportionally on energy intensive goods. So an increase in prices may affect them more than higher income households. And in fact, in high-income countries, these policies have been found to be regressive, which means that inequality has risen for the reason that I just explained. And in order to lower these negative effects in high-income countries, what has been used a lot was to work on taxes. So a lot of times countries have planned or have reduced income or labor taxes in order to decrease these effects. Of course, the problem is that in lower and middle income countries, the strategies that have been used in high income countries are not fully possible. And we suggest in this paper that instead of using or changing tax systems, is much more important, or will be much more important, to look at compensatory cash transfer schemes. And the reasons are two. The first one, of course, is the high informality. So many people work in informal sectors, and so changes in tax systems are not that effective. And the second point, which the figures in these slides refer to, is the increase of cash transfer schemes in low and middle income countries, which increase from around 80 to more than 220 in the 21st century. So there is an architecture there that can be used in order to compensate poorer households for an increase in prices. And we look at these issues in the context of Peru in this paper, and Peru is a very good case study for two reasons. The first one is that Peru as a country has had experienced very high growth and poverty reduction. And part of the poverty reduction effort has been given by the expansion of social protection and social cash transfer schemes. And the two main ones are the conditional cash transfer juntos and also the social pension, Pension 65. And both of these programs are non-contributory, meaning that they are targeted to the poor people that don't have to contribute to these programs. They are financed through the general tax revenues. And the second point why Peru is a very interesting case is that emissions have increased a lot in 21st century. And Peru is looking at how to decrease in the long term these emissions. They have not implemented yet a carbon tax, but they're considering that. So this paper we also discussed with the government of Peru in order to kind of explore the possibility of implementing a carbon tax. So given all this background, there are also other research gaps that we want to look in the paper. One is going beyond general inequality and poverty measures, especially looking at the leave no one behind principle of the SDGs. So poverty and inequality measures may hide a lot of precious information. The second is that we want to look at different type of national programs, so to see whether the ones that are there at the moment are good enough or not. And the third one is that we simulate a national carbon tax of different levels instead of a global carbon tax, which is what most papers do at the moment. So we end up with the three main research questions. The first one is, what is the fiscal poverty and distributive effects of a carbon tax? The second is, how well are the current systems, so the juntos and the social pension, placed in order to address possible negative consequences? And the third one is, what are the kind of alternatives to this existing cash transfer in order to address effects on poverty and inequality? So in order to do this, we use two main sets of data. One is the input-output tables, and we use GTAP data. And through GTAP, we calculate the carbon intensity for each economic sector. So there are 57 sectors in GTAP. And then we match the input-output data with the household surveys. And we use the NAO survey, which is the nationally representative household survey for Peru, and is the survey with the best information also on consumption. So we have more than 320 consumption items, and we match each of those consumption items to the 57 sectors that we have in the multi-regional input-output tables. And if you look at, and then we use Formula 1 from this slide to calculate the carbon footprint of each household. So we multiply the carbon intensity of each sector by the expenditure of each household in relation to that sector. So we get for each household the total carbon footprint. So once we have the total carbon footprint for each household, then we do our simulations. And first we simulate the incidence of different carbon taxes. So we simulate three different levels. Carbon tax of 20 or 50, and then there's a mistake here on the slide, but then the third one is of $80 per ton of CO2. And then we look at how these different taxes change poverty and inequality. And just as a reminder, this is a static analysis, so it's not a general equilibrium model. So we just look at the effect from a static way. So in a way, it's an upper bound because we don't take into account possible adjustments of consumption and production. And once we simulate the incidence, then we simulate the different social assistance programs, so the different cash transfer programs, and we simulate changes to the current programs and their targeting information, and then we develop those different scenarios. So basically, there are these three steps: carbon footprints. So the estimation of carbon footprints, the estimation of the incidence of attacks, and the simulations of different programs to address the effects of the attacks. So what do we find? First of all, when you look at carbon footprints, we have the left-hand part of the slide shows that the carbon footprints are quite small for the basically first 8 deciles of the distribution. And they become quite large and they increase exponentially for the last 5% of the distribution. So in a way, this is linked very much with the issue of low carbon lifestyles, which seem to be the case for the majority of the population, but the very rich or the top 5-10% seem to have a very high carbon lifestyle. And then on the right side, we see that the inequality of footprints, which is the blue line, is much higher than the quality of income. And this is, again, because the very rich households have much more carbon intensive consumption. And this can be seen also from a more detailed analysis of the carbon footprint. So, for example, on the left side, you can see that on the left side of the slide, you can see that the last decile has a much larger share of those green, of the yellow parts of the bars, which means that their footprints comes much more from fossil fuel consumption. So the story here is that while the carbon footprint is quite low for the majority of the population, it rises exponentially for the very rich households. So what happens when we simulate now a carbon tax? So a carbon tax, what it does, it increases poverty. So we see that the poverty head count, which is the FGT0 measure, increases by 6.45%. And the same thing happens for the poverty gap and the poverty gap squares. And the red circle also signifies that the statistical significance of these changes is significant at the 1% level. What is interesting is that, on the other hand, changes in inequality, so inequality decreases, but by a very, very small amount, so less than 0.5%, and all these changes are not statistically significant. So what this means is that compared to higher income countries where the tax seems to be regressive, in lower and middle income countries, and in the case of Peru, there is is not neither regressive or progressive, just very slightly progressive, but not statistically significant. So this is kind of the preliminary analysis on the effects of attacks. And now we go to the most important issue. So how can we actually compensate households for the increase of poverty that we have seen from the previous slides? So we simulate 3 types of redistributive scenarios using the cash transfer schemes. So the first one is what we call vertical expansion. So we consider the current programs and we increase the generosity of the program. So we double the transfer for the juntos program or for the juntos and the pension as well. The second set of scenarios, what we call horizontal expansion. So we don't increase the amount of the current programs, but we increase the coverage of the programs. So in our 3 scenarios, we extend juntos to all eligible at the national level. We do a universal child grant, or we do a universal basic income to all the population. So this is what we call horizontal expansion. On the other hand, in the last simulations, what we do is we take all the revenues from the carbon tax, and then we redistribute them through similar scenarios that we've seen before. So we redistribute all the carbon tax revenues to all current juntos beneficiaries, to all eligible at the national level, and to all the population, like a universal basic income. One thing I also want to mention that I forgot before is that juntos now targets the municipalities with at least 40% of poverty. Well, of course, when we extend that at the national level, we consider all the poor in all municipalities, and not just in the municipalities with poverty rates more than 40%. So what do we find? In this graph, we have that the blue and green bars are the reductions in poverty compared to the pre-tax reform. Compared to the pre-tax reform, while in the poverty headcount, in the poverty gap, while the white bars consider the amount of revenues used and they're plotted against the secondary axis. There are two main findings. First of all is that the scenarios using juntos, so a more targeted approach, have a less trade-off between the amounts used, so the revenues used, and how much the poverty gap and the poverty headcount have been reduced. On the other hand, the more universal ones, so for example, if you look at scenario 3C or 2C, you can see that there is a much wide difference between the white bars, so how much the revenues has been used and how much the reduction in poverty has been achieved. So in a way, from this graph, it seems that universal programs are less efficient compared to targeted programs. But we will see if this is true. Later. And while the previous graph was for a poverty, for a tax of 50 per ton CO2, here we compare the three different tax levels, and you can just see that, of course, when we look at the scenarios redistributing all the revenues from the tax, the 80 per ton tax achieves a much important reduction in poverty. Okay, now explain why we go beyond why it's important to go beyond general poverty and inequality measures. And one of the reasons is why they suffer from this anonymity principle, which means that they look at the difference on overall poverty and inequality between periods, but they don't look at who actually benefits or not. So this why we think it's important to go beyond this overall measures. So in this graph, I showed that the blue is the change in the poverty headcount that we've seen from the previous table. But here we decompose the change in the poverty in people that actually fall into poverty and people that exit into poverty. So for example, if you look at scenario 1A, we have basically no change in poverty compared to pre-tax reform, but this no change in poverty actually hides a lot of people that fall into poverty, so the orange bar, and a lot of people that actually transit out of poverty. So looking at the general changes in the poverty headcount hides a lot of important information. And the other important point of these slides is that scenarios with more universal coverage, of course, show the less transition into poverty because they cover the majority of the population. And here quickly, apart from the transition into poverty, we also look at the fiscal impoverishment and the fiscal gains of the poor, which is a similar concept, but not looking at transition into poverty and out of poverty, but how much the pre-reform poor gain or lose from the tax reform. And again, what we find here is that there is the general figures hide a lot of also impoverishment of the poor, but compared to the transition into and out of poverty, what the general information hides is lower. And the last point I had was about heterogeneity. So it's also important to consider the difference between horizontally, not just vertically. So for example, here we focus on difference between urban and rural areas. And as you can see, the changes are much more pronounced in rural areas, which are the blue bars. So now I will try to summarize the conclusion. So what we found was that a carbon tax without compensation would increase poverty, but leave more or less inequality unchanged. And what we found, the most important finding, was that actually by recycling even just part of the tax revenues through transfer schemes, this reform can actually decrease poverty compared to the pre-tax scenarios. And the other point we have found is that the design of the policy, so the use of different transfer programs, is crucial in achieving the social outcomes that we have seen before. And this is especially important in a country like Peru, that they now use the canon systems. and they want to kind of switch more to a transfer regime and using more kind of cash transfer schemes. And in addition, this paper looks also adds to the scarce literature on just climate policies in lower and middle income countries. And more importantly, I think we have found quite some policy implication. One is that carbon pricing, so these top-down policies to achieve lower carbon lifestyle can actually be also motivated on the grounds of poverty reduction and efforts and social outcomes, because as we see at the end, poverty can actually be reduced due to these reforms. The second one is that is critical, especially in the light of the leave no one behind principle of the SDG, to go beyond general measures on poverty and inequality and actually have a very clear picture of who gains and who loses from this policy. And in this sense, the policy design is crucial. And as the last conclusion and policy implication, we have shown compared to the existing studies that also national carbon tax can achieve poverty reduction compared to a pre-tax situation. And this is crucial because, I mean, there is all this debate about carbon clubs and the fact that it's critical that many countries implement these policies jointly to avoid carbon leakage. But actually, we've shown that even if you take unilateral action, you cannot just decrease your emissions, but also bring social benefits. And I think I'm done here. I cannot hear you.
Sorry, Daniele. Yes,
okay.
it was my small mistake. Thanks for your presentation. You were perfect on timing. Even 5 seconds were still on the clock. And also very nice presentation. I just read the comment of Jaron, and it's an excellent study with very clear results. We have a number of questions. Maybe I start with one very short. Is that in your presentation, you show these 3 scenarios where in the third one, you were actually redistributing money collected. And in the first 2, you were doubling some of the existing programs. I was wondering how much more or less you were spending in the first scenarios compared to the money collected, or was it more or less very much same amount?
No. So when we doubled the current programs, we use between 30 and 50% of the revenues. With in the case of the $50 per ton of CO2 tax, so that's not a very high level. And if we look at, for example, the $80 tax rate, it was around, I think, 10%. So a very, very low share. Of course, when we then expand the program to all the country, that's when we use a very high level. And I think for the $50 per ton, we use even more than the revenues that are used in that case. So the issue really is to decide who do we want to target with these transfer schemes.
Okay, thank you. So there is a question from Francisca. Do you account for any horizontal inequalities that Celine mentioned in her speech? Something like whether households live in an urban or rural area. Also, what is the role of these differences in a country like Peru?
So we account on that in a way that we look at price deflators. Can you still hear me?
We can hear you, but we don't see you now.
Okay, it seems that my connection is low, but if you can hear me, then I think that's
yes, it's still sufficient. Yes.
Yeah, so we account in that by looking at price deflators. So we take into account different poverty lines for different areas, and we use deflators to make price comparables. But then the simulations and the juntas transfers are based at a national level. And that's why I showed that the last slide that shows that the effects of the reform that we simulate are much higher in rural areas. But of course, I mean, going forward, I think the issue of looking at the horizontal inequalities is critical and something that we really want to expand.
Okay, thank you. A question from Inigo. Is the pattern of consumption of the society does not, if the pattern of consumption of the society doesn't change, recycling the tax through compensation measures will end up in a kind of rebound effect, which may compensate for a large part of the initial CO2 estimated to be saved. So do you look on the rebound issue in your study?
So we don't look at it from a quantitative perspective, but we discuss about that because that's a critical issue. And I don't know if you remember the first slide where I showed the footprint distribution among the population, and given that this is targeted to the lower income household and their footprint is lower than 1 ton CO2 per capita, which is very low, then we have that actually the rebound effects are very small. So in the grand scale of things, they are not relevant. The most important thing is to lower the footprints of the very high income households.
Yeah, because of the exponential distribution.
Exactly.
Thanks. Another question. Do you also have simulations generating insights about how the level of the carbon tax interacts with revenue use on poverty and inequality impacts?
I don't know if I fully understand the question, but that's in a way what we are doing in the study. So we are basically using the policies that the government is using for poverty reduction, using the proximate testing and the targeting approaches, and basically looking at the interaction between the two. So maybe I wasn't very clear in how I explained during the presentation.
Maybe this can be clarified later in Discord. Another quick question from Sasha. Do you have plan to replicate the study for other middle-income countries?
Yeah, so I mean, the problem with this study is very data intensive, but we definitely want to. And the reason why we did for Peru is that the government approached us to have a look at what would be the effects of such tax reform. So this was the original idea, but we definitely need to plan to replicate this for other countries. And if anyone has any suggestion or idea, I mean, I would be more than happy to discuss this as well.
We almost out of time. Maybe last question. You did your study on carbon tax. What is your perception idea how carbon market would work differently in a country like Chile?
This is a very good question. I think we did the carbon taxes also because it's very easy to implement from a computational point of view, because our assumption was that the increasing prices are shifted to the consumers. So that was very easy. But of course, ETS and trading schemes are kind of more politically feasible. So I think it's more a question of, I think, also political feasibility in this sense. But I mean, of course, there is this, I think, assumption that also carbon taxes in a way are also easier to implement, and they could also reduce informality in some lower and middle income countries. So I don't have definitive answers. There are kind of pros and cons for both approaches.
I think this discussion we can move to session P4, because there will be a separate section on acceptability of climate policies. Thank you again, Daniele.
Thank you.
And now we proceed with Marion Leroutier from Paris School of Economics and CIRET Lab. So Marion, the floor is yours.
Thank you, Ivan.
Fulvia, could you please?
I'm sorry. Yeah.
Or maybe
sorry, we are having a bit of issues with loading your presentation, Marion. So maybe we can proceed with the next presenter, and then we try again with yours.
Okay. Sure.
Sorry for that, Marion. Then I give the floor to Emilian. Emilian, is it okay if you present now?
Yes, I think no problem. Thanks, Ethan.
So Emilian is also from CIRET Lab. He is colleague of Celine, and actually I think he is one of the few colleagues.
Sorry, back again. We are ready with Marion.
Okay.
Well,
sorry.
No, it happens. Okay. So then Marion back again.
Okay.
Please.
Thank you. Sorry for the inconvenience. It's my fault because I updated my presentation a bit last minute. But thanks everyone again for attending this presentation. So this work is about also the distributive impact of low carbon policies, but in the framework of transport policies and in a setting of polluted cities. And I'm going to take the example of the Paris area. I should also mention right away that this is an exercise in the context of hypothetical low carbon transport policies. So I'm trying to infer from current carbon footprint and current exposure to environmental damages, who is likely to benefit and to suffer from low carbon transport policies. So the motivation for this work is, I think, three important things about the transport sector. So first, as you may know, transport sector is a large contributor to greenhouse gas emissions. So in the EU, for example, it's 27% of total greenhouse gas emission. Oh, I'm sorry. I realized I didn't. How can I? Sorry, because I'm actually using my phone and I don't really know where I can.
Just let me know when you want me to go on.
Yeah,
and I
okay.
will do it.
I'm really sorry for this inconvenience. So you can go to next slide. Yes, this one. So I was saying the transport sector is an important contributor to greenhouse gas emissions. And notably in the EU, emissions from transport have been rising again since 2013. So the trend is really looking bad. And within transport, road transport is the main contribution to emissions. The second point is that the decarbonization of transport sector raises issues of social acceptability. And as it was mentioned in the previous presentation, we know that carbon taxes are in general regressive. And we saw what happened in France where carbon tax was increased. We had the yellow vest protests. And the third point is that when it comes to the transport sector, urban areas are somewhat of a specific case. So on the one hand, there are more alternatives to car in urban areas in general. Urban areas are more dense. You have public transportation. It's easier to walk or to cycle. So in general, car represents a lower modal share. But on the other hand, car use in urban areas in general is associated with more direct environmental nuisances compared to, say, rural areas. So generate noise, and specifically what I'm going to focus on today is the air pollution associated with car use in urban areas. So I'm talking here about the kind of the local air pollution that is damaging for health. So the question, therefore, is whether the desirability of low carbon transport policies can be enhanced if you incorporate the prospect of immediate and direct air quality improvements that are associated with these low carbon transport policies. Next slide, please. So in this paper, what I do is to estimate today whether the same groups of individuals who are responsible for carbon emissions and air pollutants emission, and are these people the same as the people who are currently most exposed and suffering from the induced, the air pollution induced by car use. So indeed, I consider jointly, on the one hand, individual contributions to transport-related CO2 emissions, so in a way, carbon footprint from transport in the Paris area. I consider the same footprint, but for local air pollutants. And on the other hand, I measure individual exposure to air pollution, and I measure this exposure to air pollution during a representative weekday. So I do not only measure air pollution at the place where people live, which is usually done in the literature, but I try to improve their measurement of exposure to air pollution by incorporating exposure when people travel and in all the places that they visit during a typical day. Next slide, please. And next. Thank you. So a bit about the local context. So the Paris area, so first in the Paris area, road transport contributes a lot to emission. This is true both for greenhouse gas emissions, it's about a third. And this is also true specifically for local air pollutants, in particular for nitrogen oxides. So the transport sector is responsible for more than half of the region's NOx emissions, and it's the kind of local pollutants that I'm going to focus on during the presentation. Second, in Paris, it seems like in terms of environmental concerns, air pollution is maybe more of an issue both for the people and for the local government than climate change. this is evidenced by the fact that so air pollution levels are very high. Surveys mention that more people think that air pollution is the number one environmental concern than compared to climate change. And finally, the local transport policies seem to be driven a lot more by air quality concerns rather than climate concerns. So, for example, the flagship policy recently has been rolling out a low emission zone in the next period. Next, please. And finally, just like for the national level, a social justice or social inequalities arguments are often brought about in the policy debates around regulating car use and low carbon transport policies. So typically the cliche, which may be true in other big environmental cities, is of this rich, eco-friendly bikers who live in central Paris, who don't really need a car and who are in favor of these environmental policies, against poor car-dependent commuters who really are dependent on their car to come and work in the city center and who live in the suburbs. So in a way, my work is also trying to see whether this is only a cliche or whether there is some truth in this. Next. And next. So for this work, so it's a really descriptive work where I'm gathering 3 sources of data. The first one is a survey of a representative sample of 35,000 individuals in the Paris area in 2010. And for all these individuals, we know exactly on a representative weekday where they've been, what kind of transport mode they've used, and how long and they've traveled and the distance they've traveled. And we also know the characteristics of the vehicles that they've used for their transport. And I combine this with geocoded data on NO2 concentrations in each gridded cell of the Paris area. I have very precise data for every grid of 50 meter by 50 meter in the Paris area. And finally, I combine this with emission factors for CO2 and NOx, so local pollutants. So emission factors are quantity of emissions by kilometer driven for a lot of different transportation modes with a lot of details in particular for cars. Next, please. And so with this data, the variable that I'm interested in is an individual pollution exposure to NO2 in the Paris area for all these individuals, which is based on the pollution levels in all the places visited by these people during the day and the time spent in each of these locations. And second, next. And second, I build this individual emission contributions or footprint for both CO2 and NOx pollutants, which are this time based on the emission factors of all the transportation used by these people on a representative weekday, and combined with the distance travel with each mode. And next, please. And finally, so I analyze how unequal is, on the one hand, the distribution of exposure to pollution, and on the other hand, the distribution of contribution to emission. And I specifically investigate the role of income. Next. So the result. So first, how unequal is the distribution of contribution to emissions? So what I've represented here on this graph is a Lorentz curve in the same spirit as the previous presentation. So on the left-hand side, you see on the x-axis, it's the contribution or the carbon footprint related to travel of all individuals from my survey, ranked by ascending footprint. And on the y-axis, you can see the cumulative contribution. So what you see on this graph is that it's very unequal, and you can see that the bottom 80% of people, they contribute to only 25% of the CO2 emissions related to travel in Paris, while the top 20% contributes to 75%. And on the right-hand side, you see that it's pretty much the same for NOx emissions. The two are very much correlated and linked to how much you use your car and how long you travel. And so for NOx, it's even a bit worse. So we see that it's quite unequal. And now if we move to exposure to emission, next please. When we look at exposure to pollution, so this time I represent on the x-axis again the population ranked this time by exposure to pollution, and on the y-axis is not a cumulative contribution, it's simply the absolute value of how much pollution they're exposed to during the day. And in blue, you can see the average exposure to pollution based on the place of residence of people. And you see that even if we say Paris is very polluted, actually you have a lot of heterogeneity, because this exposure ranges from 10 microgram per cubic meter, so it's mostly in the outskirts of Paris, far from the center, to 80. So this would be in Paris center, which is very high. And the horizontal line at 40 microgram per cubic meter, it's the legal threshold and the threshold recommended by the WHO. So you can see that 30% of the individuals in Paris are above this threshold. Now in red, sorry, can you move back to the previous one? And in red, what you see is what happens when, instead of relying on the exposure of people to pollution based on their place of residence, what happens if you also include the concentrations of pollutions in all the places where they go during the day, including the pollution in the transportation mode that they use. So for example, when you take your car, it's a microenvironment that is actually really, really polluted, especially when there is a lot of traffic. And what you see here is that it reduces inequality a little bit when you take this measure of exposure to pollution, because the kind of people who are on their place of residence less exposed to pollution are usually the ones who travel to the center, which is polluted, to work, and also use that car more. And the car is a very polluted place. So you see that once you start including this dimension, you see actually a bit less inequality in exposure to pollution. Next, please. And now what we want to do is to see side-by-side contribution and exposure, and to investigate whether it's the same kind of people who contribute and who are exposed to pollution. So what I show here is the same kind of Lorentz curve as for the footprints, except that this time on the x-axis, I've ranked the individuals not in terms of their contribution to emissions, but in terms of how much they're exposed to CO2 emission. And the shape of the curve, the blue line, what it shows you is that it's actually the people who are the least exposed to pollution tend to contribute more to emissions than the people who are more exposed to pollution. So you see, for example, that the bottom 40% of exposure to pollution, they're actually contributing to 60% of the emissions, and this is emissions for CO2. And on the right-hand side, what you see is, again, what happens if you switch to a measure of exposure to pollution based on all the places visited during the day. And again, you see that it decreases inequalities a little bit, again, because those people who contribute to emissions are also exposed to the pollution during their polluting behavior, as in taking their cars. Next, please. And finally, what I do is to look at the role of income in this. So I take again my population, and this time I order them in deciles of income, and I simply check what is the contribution, the emission, the carbon footprint, and the local pollutant footprint by decile of income. So on the left-hand side, you see that you have an increasing and concave curve for CO2 emissions, which is quite consistent with the rest of the literature on carbon footprint. And on the right-hand side, you see that for NOx, it's a bit different, because it decreases the NOx footprint, the local pollution footprint tends to decrease with income, which is linked to the fact that high-income people tend to have newer cars, which are on average less polluting in terms of local pollution. And now what happens for exposure to pollution in terms of the income level? So you see the same kind of graph with the exposure to pollution on the y-axis. And here we see that compared to a lot of the literature in the US notably, which tend to show that low-income people are much more exposed to pollution, actually when it's measured with NO2 in the case of urban areas like Paris, it's high-income people who tend to be most exposed to pollution. And this is true both when you consider exposure at the place of residence, this is the blue, and when you also include the places visited during the day, which is the red line. And yeah. no, it's fine. So what can we conclude from this? So we saw that both emission and exposure are unequally distributed in the Paris area, and those who contribute to transport-related emissions are not the same who suffer from the associated air pollution. So now if we think about what this would mean in terms of if you implement a low carbon transport policy in the form of carbon tax or restriction in car use, what does this mean in terms of who is going to reap the benefits from it? It seems like the highest benefits could be achieved for the very poor because they contribute very little and they still have medium exposure to pollution. And the lowest benefits could be for the median households because we saw that there are the ones who tend to contribute a lot to pollution, but they're only medium exposed to pollution. And finally, the results are more ambiguous for the richest household. On the one hand, they contribute a lot to emissions via their transport decisions, but on the other hand, they're also the most exposed to local air pollution. And maybe to conclude for the discussion, I think it's also part of my next steps, but when we think about lifestyles, what misses here from the analysis, and what I'd like to do is also to distinguish in this carbon footprint between sort of avoidable and non-avoidable car emissions, maybe looking at what would be the alternative transportation in the places where the people live and whether the car use is really necessary. And second, during this analysis, I realized that the policy instruments that target local pollution compared to global pollutions, CO2 emissions, may have different distributive impacts. So, for example, if you look at the emission factors of cars, depending on the income, we see that age is really the main determinant of emission factors for local pollutants. And typically, it's higher income households tend to have newer cars and will have much cars that are less emitting on that side. While for CO2, actually, the determinants of a car CO2 emission is more linked to the weight and the horsepower of this car, and actually higher income people tend to have heavier and more sort of cars with higher horsepower. So in general, they will be more affected by CO2 tax, for example. And that's it. Thank you.
Thank you, Marianne. We are also good in time. So we have about 5 minutes for questions. And I see there are already quite many that have been collected. So there is a question of Theo. Given your results, how should we adjust carbon food taxation to take into account these health co-benefits? What do you think? Is there any policy recommendation from your analysis?
Carbon food taxation?
Carbon fuel taxation. Sorry, fuel.
Well, so for sure, there's a bit of a trade-off we know between the air pollution and the greenhouse gas regulation objectives, because typically diesel has been less taxed than gasoline because it was more efficient in terms of the CO2 emission factor. But we also know that for old cars, the diesel ones are much more emitting in terms of particulate matter. So I think in terms of policy implication, if you only target cars without investing in infrastructure that offer people other possibilities than just choosing between diesel and gasoline car, you will almost always have a trade-off between this air pollution and climate change mitigation objectives. So hence the importance of thinking beyond just changing fuels
Car type.
and car type.
Okay, thank you. Another question comes from Katya Vladimirova. A very interesting study clarification question. How did you disentangle pollution from transport, from emission, from industry? Did I understand correctly that overall pollution in Paris suburbs is lower than in the center, both transport and industry?
Yes, so here, when I consider exposure to pollution, it's true that in the concentration that we have, we know that there are multiple sources, and we know that transport contributes only to half of this. So I don't try to distinguish. So when I present exposure to pollution, this is exposure to pollution in general. And we know that NO2 is the single pollutant that is most closely related to car use. So that's why I only use this pollutant, but it's true, I don't distinguish. I don't isolate the share of exposure to pollution that relates to transport rather than industry. And it's true that NO2 is much higher in the center than in the suburb, but this mostly relates to the higher density of car use in the center than in the suburbs.
Another quick question, how much you could reduce the overall pressure of pollution by relocating jobs and home closer to each other? Do you think there is a potential behind such a policy measure? So to let people move less between home and work?
So for sure, a commute to work is a very important determinant of how much you're going to emit and how much you're going to have to use your car. So for sure, it would contribute. I guess this is always a trade-off between this and the breadth of opportunities for jobs. And if you look closer to your area, you would have probably fewer opportunities. I've been interested recently in works on gender gaps, and some of the recent work which is showing, for example, that one factor explaining the gender wage gap could be that women are in general looking for jobs much closer to their home, which restricts the universe of jobs that they can look for. So just to say that there are trade-offs and it would be part of the solution, but it's maybe not that easily feasible. And
I'm afraid we are already running out of time. There are Eva. So Eva actually did her master in political ecology at ICTA. So some of the participants of the conference may remember and know her well. Now she is living and working in Berlin in a consultancy company, Prognos. And she is going to present us results of her master study. So Eva, the floor is yours.
Okay. Thanks for presenting and everything. So now after the view from the macro side, I'm gonna come to more shorter example. And like Ivan said, I'm gonna present the results from my master thesis, which was on the contribution of eco-communities in achieving energy and climate targets. And I'm from Germany, and I was working and living in Germany before, so that's why I choose Germany as an example for my analysis. And just a short overview of the slides. It's more or less the same than the ones before. First, the background and motivation for the research, then the methodologies I used, and from this, the results, conclusion, and recommendations, especially policy recommendations. So, like I said, one reason was it was my master thesis, so which I did together with Claudio Cataneo as a supervisor, also from ICTA. And the other reason or motivation is which I will keep short because we were talking about this a lot already yesterday and today. We need to reduce carbon emissions as fast as possible to achieve the Paris Agreement. And until now, most countries, as Germany, which is shown here on the right side, are far away from reaching their own targets, and these targets are not ambitious enough for the Paris Agreement. So we need to be a lot more ambitious. But on the other side, until now, climate mitigation is focusing on renewable energies and energy efficiency with all the obstacles that a fast upscaling has. And also, if we look at other technical solutions like nuclear energy or carbon capture and storage, which BECCS is one of these, there are a lot more problems from a sustainable point of view. So this is why we also need non-technical solutions. And I think I don't need to discuss this too much because it's also why we are having this conference. And what was also mentioned quite a lot is if we come to these non-technical solutions, demand-side solutions, this sooner or later involves a discussion of values and also of human needs in the context of sustainability. And to have an approach to this, I choose to focus on eco-communities because they are recognized as kind of best practice cases for sustainable low-carbon living, but on the other side with a high quality of life. There's already, especially over the last 30 years, a lot of research on eco-communities that prove this. But what's interesting, there's actually not that much empirical quantitative data on the ecological impact, especially on energy use and carbon footprint. And this is why I choose the research question to see how and to what extent do German eco-communities contribute to achieving climate targets and what are insights for energy policy. To answer this, I have a mix of methodology, a more quantitative part, also not a big model, and then also a qualitative part. And in the quantitative analysis, I collected data from 6 German eco-communities on their energy consumption, and from this calculated the specific energy consumption and the specific GHG emissions per person. On the right-hand side, there's the steps I made. I think most important, the commercial activities were subtracted, which isn't always that easy to make a distinguishment because, for example, a lot of eco-communities run seminars or have their own bakery and all energy consumption is just measured together. And then I also did a temperature adjustment because I had data from different years. And by dividing by the number of residents, I got the specific energy consumption, and with the corresponding GHG emission factors, I concentrated on direct GHG emission, also the specific GHG emission per person for the respective eco-community. And this results I compared with the current German average, and also because I want to see how much they already contribute to a low-carb lifestyle, which results from an ambitious energy scenario that has 95% reduction of GHG emissions, which is not quite net neutrality, but it was a scenario where data was available, and it's not such a big difference after this. And the second part of the methodology was a qualitative part, because I wanted to discuss these quantitative findings and also learn about the topic of well-being, which need to be linked with the low-carbon lifestyles if people want to adjust to them. So I choose one eco-community for a site visit, the eco-village of Siebenlinden, more or less in the north of Germany. And it's a very interesting example because they have a very low ecological footprint and also especially low energy consumption and low GHG emissions. And I went there for a weekend seminar for people interested in the community. So I learned a lot about the community. And beside this, I had one semi-structured interview with one of the community members. So I concentrated on Siebenlinden, but with the other eco-communities, I was also in contact, mainly via email, sometimes per phone, and I got some more additional information, especially on the energy use, and cleared some questions. So with this, to the results. First, the residential energy consumption, because I just focused on the residential energy use. It's without energy for transport, because it's a lot more difficult to get data on this. And on the right-hand side, the 6 communities. So say a short introduction. One was Vliershof. It's a quite small community near the Netherlands. Sulzbrunn, it's in the south of Germany, and it's quite newly established, 5 or 4 years ago. Then Schloss Thondorf, it's in an old castle, middle of Germany. Then Siebenlinden, that is the eco-village with around 140 people, which I also choose for the site visit. And then there are 2 eco-communities that are also more political communities, Kommune Waltershausen, with around 20 inhabitants, and one of the oldest political community, Kommune Niederkaufungen, with around 70 to 80 people. Just to have a very short idea how these eco-communities look like and how they are also diverse. And if we look now at the graph, on the left-hand side is the average energy consumption per person in Germany in the year 2018 in kilowatt hour per person. It's around 8,000 kilowatt hours. And actually the average of the 6 communities I analyzed, it's also more or less around 8,000 kilowatt hours per person. So from this, just the heat of the consumption, actually it's not that different to the German average. But of course, if you have a closer look, there are differences. There is, especially if you look at the share of energy carriers, and the German average fossil fuel with around 16% is a lot. As the highest share, renewables just 14%, and around 30% electricity and district heating. And in eco-communities, there's just one exemption, Sulzbrunn, with a very high fossil fuel share, around 80%. And all of the other 5 communities have a high or very high share of renewables. Actually, that's mostly wood that they use for heating. And also about the heat of the consumption, Sulzbrunn, as I said, which is still being established, has a very high consumption per person. But also 2 of the communities, Siebenlinden and Kommune Niederkaufungen, show that it's possible to have a remarkably lower energy consumption with around 5,000 kilowatt hour per person than the German average. And if you compare it now to the target scenario, that's the second one on the left side, Germany KS 95, we see that we need to even halve energy consumption to get to this low carbon scenario. But still, some of the eco-communities are already near to this target. And if you have a look at the corresponding GHG emissions, again, on the left side, the German average from residential energy use, it's around 2 tons per person and year. And there's only one community, so it's Brunn, which we saw with a high share of fossil fuel that has higher GHG emissions per person, 2.8 tons. And all other 5 communities have lower emissions, which is mainly due to the use of biomass, wood, and also some solar energy, solar thermal and photovoltaic. And of course, also because of the lower consumption. And 2 communities, Siebenlinden and Kommune Waltershausen, are getting very near already to the target of less than 100 or less than 50 kilogram CO2 equivalent per person. So this is the results from the quantitative part. And I think what is interesting now to combine it with the qualitative findings. Here on Siebenlinden, first of all, on the topic of energy demand, they use and developed their own building technique for energy efficient houses. On the left side, you see a picture of one of the first of these houses that are built with straw. So it's a technique they developed, which is very sustainable and also very good insulation. So from this, energy demand is already quite low. But apart from this, it's also measured yearly. And if the demand is rising, a discussion takes place, and normally also some measures are taken. Then on the firewood they use for heating, they grow it in their own forest. So it's a very short cycle they have. Just behind the village is the big forest, and they have a forest team that's taking care of the forest and also preparing the firewood. And then people just need to transport it to their boilers. And then apart from this, it's a very easy heating system and also comfortable. I was there in November and it was really quite warm and comfy. So it's not that people have a low energy consumption because they are suffering in their cold houses. And then on the buildings and living space, they set the rule when they founded this eco-village that not more than 16 square meters per person should be overbuilt. That means if it's a 2-store house, which are most of the houses, per person, the living space is limited to 32 square meters per person. And they achieved this by living in shared multi-person houses, either with their families or in shared flats. And then more general on life in eco-communities, it requires time for community duties, for negotiation processes and volunteering, which is encouraged. But it's also one of the reasons most people say they want to move to an eco community, or why they choose to live there. And there are also a lot of methods developed how to organize this community duties and how to deal with conflicts. So when it comes to the overall quality of life, most people are very happy and satisfied. This term of living life in abundance was mentioned. And what is also something that was highlighted, that the infrastructure they created encourages sustainable patterns, not only for the housing, which we saw with the low energy demand and GHG emissions, but also in other spheres of life, for example, for food or for transport. And so even if it's in a very rural region with not that much perspective around, people living there are satisfied with their life. Okay, so to conclude from this, like I said, from the quantitative data, there are evidence that the energy consumption isn't, the heat of the energy consumption isn't that different to the German average, But if you look at GHG emissions, it's clear that 5 of the 6 eco-communities I analyzed have a lower GHG emissions. And on the other side, they have they're quite satisfied with their life and found also solutions how to organize themselves. So would it be a solution for low carbon life that everyone moves to eco-communities? Of course, it's not that easy, and we can't upscale the findings like one-to-one, because I only looked at rural communities, and in cities or more dense spaces, the situation is very different. Challenges are also different. And the other part is one of the reasons for the low GHG emissions is the use of biomass, which is possible in these rural niches, but it's nothing that we can transform to a whole country, especially not in Germany. And another limit is that Siebenlinden, this very interesting eco-village I visited, they had a special opportunity to build a new eco-village from the start. But what is interesting and can be transferred to a whole society are other points. First of all, the importance of social innovations. Like I said, not only the technical solutions like this sustainable energy efficient straw bale houses, but also how to organize the housing and the flats and the people there. And then also the importance of limits. The nice example from Siebenlinden is that I said we want to limit our living space, and then they find possibilities how to do this so that the housing situation is satisfying for everyone, at least most of the time. And with this, also the just decision-making processes and dealing with conflicts, which is something that is very much and well elaborated in eco-communities, is very important. And all in all, what can also be seen is that in the end, it's the infrastructure that determines everyday consumption patterns. It's not so much a choice you do every day, it's more like how your day-to-day life can be organized. And with this, some recommendations. First, for policy and energy policy, we need more ways of try and experiment with low carbon lifestyles, because there's not one blueprint there, but a lot of things just evolve when they are really lived. So settings for upscaling is necessary. Then concerning more energy policy, the topic of limits is very important. We already have a kind of a limit by the carbon budget and by our targets, but it needs to be brought down also to the different spheres of energy consumption. And for this, I think very important is the integration of energy sufficiency measures. For one thing, in energy modeling, which is one of the tools for energy policy, with all the problems and challenges we were discussing over the last days, but also in real policy measures. And apart from policy, I think that there is also a lot more interesting research to do. For example, maybe also going on the different factors that enable the low consumption in detail, how this can translate to routines and low threshold measures for average households, and also to maybe linking it also to the degrowth discourse, to analyze how carbon and social footprint of commercial activities in eco-communities differentiate from mainstream economic activities. So,
Thank you, Eva.
Yeah.
Thank you for the very nice presentation with many interesting examples and food for thought. We actually collected a number of comments and questions. I'm not sure you will have enough time to answer all of them, but let's try. Okay. I will start with chronological order. A question from Jaco is about whether you used any theory for your qualitative analysis, or maybe if not, maybe there is a framework which could fit to your analysis?
Maybe I used a theory for the quantitative part on the social metabolic analysis, but I left it out here because of time. For the qualitative part, I didn't really use that much of theory, more, but I think there's a lot of theory on social innovations and also on the concept of social innovation and how to, and how to define it. I didn't went very deep into this. Just read some literature on this.
Okay. Very quick question on the community in Salzburg. I think it attracted a lot of attention. Its emission was higher than the German average. What happened there?
It's quite interesting. They founded the community in 2015, and it's in an old It was an old sanitarium, so they have, I think, from the last 100 years, they have different buildings, and some of them are not very well insulated. And they also have an old fuel oil heating, which they already replaced. So I was still in contact with them, but I didn't get the data for 2019, which would be interesting because they changed actually to some kind of wood heating. So I think GHG emissions would be lower for 2019. And I'm not sure about the consumption. Maybe it will be also lower. But it's, like I said, it's kind of, it's work in progress. So that's why they are maybe distinct from the other 5.
In your examples, you had this use of wood for heating, but do many communities also have renewable electricity installed, photovoltaics?
Yes, that's what I also said. I had, I don't know.
That was actually a chart with some figures. Okay, but for example, the Sieben Linden particular.
Sorry?
No, we were talking at the same time. I'm sorry, but I think once you said, I also recall there was a chart with different colors demonstrating the proportion. Also,
I can put the share of wood and PV and solar thermal. I haven't, but I thought it was too confusing in one slide. But I can put it in the chat. So maybe that's. But actually, wood is the highest share because it's used for heating, and this is higher than electricity consumption. Just in short.
Several people highlighted the issue of limits of space. One of the question is, do you think there is a potential to translate these limits of living space into a policy recommendation somehow?
Yes, I think so. And there is also some, there are already some proposals and some more literature, especially on this reduction of living space and some measures that could be taken. For example, that older people that live in big houses after the children move out change house with new families, for example, that can't find a living space. And there are also some other ideas, but I think what will be difficult is to say in a law that no one is allowed to have more than, I don't know, 30 square meters or something. I think that won't be possible, but there are ideas how to make more workable policy out of this.
Another interesting question is, do you know anything about the social demographic characteristics of people living in these communities, in particular about their political views? Are majority of people there kind of left-wing oriented or not?
So I think the first part could also be about age. So that's on this. At least in Sieben Linden, people are younger than in the villages around, which are quite abundant. And on the views, I think 2 of those communities are political communities that are very, very left-wing political view. And I think the other ones, it's a mixture between maybe a bit apolitical and probably more on a left-wing side, but I didn't go that much into the details into this.
Okay. Thank you. I know there are more questions which we could address now, but since we in principle already out of time, I suggest that everyone takes time and discusses the remaining on the Discord, because really there are at least 5. I simply didn't have time to say.
Yeah.
Thank you once again, and thanks to all the 4 speakers. I just want to remind that in 70 minutes, so 3 p.m. Central European Time, now we will have a break, and in 70 minutes we will have a next session. So I hope to see many of participants there as well. Thanks for being with us, and see you again.
Yeah,
Bye.
thanks for moderating. Bye.